All right, today, last section of chapter 4. And we're going to be using isosceles and equilateral triangles. So let's take a close look at isosceles triangles. What we really know about them is that two of their sides are congruent. So for an example, these two sides could be congruent to each other, or these two sides could be congruent to each other. What we're going to learn today is because those sides are congruent, I know something else about them. And what I know about them is something called a base angle. So these angles right here, the ones that they stand on, those are called base angles, and they are congruent to each other. And so if I take a look at the other triangle, these two angles, these are also called base angles, and they are congruent to each other too. And then you're going to notice it says, what's a base angle versus a vertex angle? Well, the other angle, the one that forms the hat, that's called the vertex angle. So what does this do for us? Well, if two sides of a triangle are congruent, then I know that their base angles are congruent. Also, if they tell me that I have an isosceles triangle, I can also say base angles are congruent. I can also do the converse of that. That says that if I have two angles of a triangle are congruent, then I know it's an isosceles triangle. Or if it tells me the base angles are congruent of a triangle, then I know that it's an isosceles triangle. So the converse is also true. And this is really important, not only in proofs, but just working general problems. Equilateral triangles. Equilateral triangles, all the sides are congruent to each other. That's what makes them equilateral. But I also know if they're equilateral, they are also equiangular. Okay, so when it says if a triangle is equilateral, then it is equiangular. Or if a triangle is equiangular, then it is equilateral. So, some properties about isosceles triangles and equilateral triangles. Let's take a look at this in action. If I take a look at this, notice that I've got these hash marks right here. This tells me that it's equilateral. Because I just learned some really cool stuff, I know that it's also equiangular. So if you remember back a ways, we talked about triangles. All triangles, their angles add up to 180 degrees. And so if I have 180 degrees in a triangle and I divide it 3 ways, I know that each one of these angles is 60 degrees. And that's helpful for us. So because each of those are 60 degrees, I know that x, because it's by itself, is going to be 60 degrees. And yes, I'm going to use degree measure. It's not side measure. I'm looking at angle measure. I know that 2y is also going to be 60 degrees. If I divide by 2, y gives me 30 degrees. I know that 3z equals 60 degrees. So if I divide by 3, z gives me 20 degrees. And so something that looks so complicated and spooky really wasn't that bad at all. Let's go to the next problem over here. I know this is an isosceles triangle, because I know that because of these two hash marks here and here, I know that their base angles are congruent. So this angle is congruent to this angle. So I can go 4x minus 7 equals 3x. Use my algebra magic, negative 7 equals negative x. Subtract my 4x. Then divide by negative 1, and I get x equals 7. Something that looks pretty scary actually is pretty basic. All right, let's go on. Now this one's a little bit loaded. So we're going to take a look at that. If I take a look at this a little bit closer, I know because of these angles here, I know that's an equilateral triangle. Okay. I also know that because of this angle here and this angle here, that other one is an isosceles triangle. So what I'm going to do is I am going to shade this purple. Just so you can kind of see it a little bit better. So here's my purple triangle. Notice that it's an isosceles triangle, and I know it is because of those base angles. I know that this side is congruent to this side. And then if I take a look at the other triangle, I'm going to shade this pink. Notice that all the angles are congruent, and I know that because they did those little hash marks. I know that this side is congruent to this side is congruent to this side. Okay, now one thing to keep in mind, you're going to notice that this side right here, because it's a 1 hash, is congruent to this, which is also 1 hash, but it's also congruent to this one and this one. Okay, so there's a lot of things related here. So what I'm going to do is, because this side is a 1 hash and has an x, and this side also has an x and a 1 hash, I can take 4x plus 2x, 4 plus 2x, and I'm going to set that equal to 5 plus x. So I'm going to use my algebra magic. I'm going to go ahead and go 4 plus x, because I'm going to subtract x from each side. I'm going to subtract 4 from each side, so x gives me 1. And I just solved for one of my variables. Now I've got a little tricky part. I've got this thing in the middle, and it's got a y. Now notice that that side, that 3y squared minus 6, is equal to 5 plus x, because it's an equilateral triangle. So I'm going to go 3y squared minus 6. I'm going to set it equal to 5 plus x. And you go, whoa, this isn't going to work because I have 2 variables. But remember, I just solved for x over here, so I can do 2 variables, because now I'm going to plug in that 1 for x. And I'm going to go 3y squared minus 6 equals 6. I'm going to add 6 to each side, so 3y squared gives me 12. Divide by 3, y squared gives me 4. And now to get rid of that square root, I'm going to square root both sides. And yes, you need to show the square root. So y gives me 2. All right, that is it for chapter 4. Again, we're going to have a test pretty soon. If there's any questions that you have about proofs, isosceles triangles, or equilateral triangles, don't hesitate to let me know.